So, continuing our discussion for finding out the efficient frontier, till now we have discussed that n number of risky assets are there. Then the next case we consider n number of risky assets plus the nth one is the risk free one is there, and you can basically now understand that given these two combination, we would also be interested to find out that what is the case for finding out the for these two instances where both short selling is allowed and not allowed. So, very simply or conceptually would be for the curve, it will be an extension with dotted lines, which we have already discussed would be for the short selling case, and for the straight line it will be extended where you will basically borrow from the bank and try to basically invest that amount in trying to buy different type of assets. So, the borrow from the bank is basically you are borrowing from F or RF and trying to invest in point Q. So, we will very briefly discuss here the concepts which are that short selling allowed along with riskless lending borrowing possible, short selling allowed, but riskless lending borrowing not possible, and in the next two instances would be short selling would be disallowed, that means short selling is not allowed, with riskless lending borrowing is possible in one case and not being possible in the other case. Now, what we mean by short selling and riskless lending borrowing possible, let us make the distinction. Short selling, when I mean the word short selling, it is respect to the risky assets only, point 1. Point 2, when I mean my riskless lending borrowing being possible and riskless lending borrowing being not possible, it is a different way of saying that short selling is being allowed for the risk free interest rate. So, if we are allowed to lend, it means that we are taking money from the bank, utilizing them in our basically n number of risky assets, which means in a way short selling is being allowed for the risk free interest rate. So, basically this is a combination of short selling being allowed, but we are making a distinction that for the RF and for the n number of risky assets, the overall conceptual framework how we analyze the problem would be different. And the last one being where we incorporated different type of constraints and assumptions on our problem. Short selling being allowed along with riskless lending borrowing possible. So, let us analyze this problem very simply. We have already done the techniques, but we will try to basically give a conceptual framework. Consider the curve which you have in front of us is what? Is the feasible set. Now, once we basically use the concept of trying to find out the efficient frontier, the efficient frontier would be, let me change the color, would be from the minimum variance point till the value of Q and then extended depending on whether riskless lending borrowing is there or not, short selling is there or not. Now, what we do is arbitrarily take the risk interest rate as given and then turn the tangent point which you want to achieve in such a way that it turns counterclockwise. So, as you are turning it at one point of time, it will just touch the curve which is the efficient frontier which you have, and that point will be the point of Q which we can find out using the Lagrangian. So, what we are doing is that if short selling is allowed, then it will be just an extension of the tangent point towards infinity, which are the dotted lines. And if lending and borrowing is possible, obviously it will also mean the same case where lending and borrowing is possible for the risk free interest rate. So, which means that the point F and Q when extended till infinity would basically consider all the cases of lending and borrowing possible and short selling being allowed for the case. So, what we will do is that first we may solve the curve, find out the point of Q and then join Q and F and extend it to infinity to get all the combinations of points. So, what I mean the combination points is basically a combination of the weights which you want to find out, which is of more importance to us. For short selling allowed along with riskless lending borrowing possible, turn it counterclockwise, the efficient frontier is the entire length of the ray extending from F to Q. Remember, the loci FQ is the tangent of the point of Q which you already found out. Different point on the lines basically denote different combinations of the weights for this n plus 1 number of assets which we have. Thus, what we are trying to do is maximize the tangent value. So, if you see the numerator is basically the height which is r bar q suffix q, which is the return for the q point, minus rf. So, that means if we go back to the slides, it is this height. And what is the base? Base would be simply the sigma q point which you have. So, this is this point, and what we want to find out is the tangent theta. So, such that the weights is 1, there are two solutions we have already discussed. One is the Lagrangian one, we will discuss that only for the time being, but as the other procedures may be a little bit more cumbersome, based on which we will try to discuss that later on, once the fundamentals have been built up. Now, if you basically expand this equation, you will feel the numerator has basically the difference of the Ri minus Rf. So, this is very simple, because the first equation was basically point in the numerator was Rq. So, make Rq as summation of Wi's into Ri's, and then you basically get the point which is Rq. And in the denominator, what you have is basically the variance of q point, which is sigma suffix q. So, what you have is basically summation or double summation of Wi Wj into sigma ij square, and basically you try to find out the square root of that. The solution is given if this in a very simple way. When you formulate as a Lagrangian and then again solve it, it will give you basically very simply n number of equations. Now, you may be asking the question that from where do we get the n number of equations? So, solving each of them with respect to the assets would result in n number of equations. So, what we have is basically n number of equations with n unknowns, and if they can be solved, immediately you can find out all the weights accordingly. So, let us basically give the solution technique as such, where we have for k is equal to 1 to n, this is the number of assets which you have this equation. Now, there are two important points to be remembered. As you change k 1 to 1 n, in each equation you will basically have n number of terms. So, the first equation would basically have the first term, which is stock 1 to stock 1 itself, second term will be stock 1 to stock 2, third term will be stock 1 to stock 3, so on and so forth. The second equation would be stock 2 to 1, 2 to 2, 2 to 3, so on and so forth. And the last one would be stock n to 1, n to 2, n to 3, and the last one would be nn. So, if you visualize, what you are doing is that you are trying to utilize the covariance variance matrix in order to find out the best feasible point. But remember one thing, if you remember the concept of normalization, here the weights which we found are non-normalized, hence we need to basically convert them in the normalization case such that the weights add up to 1, and based on that we can find out the overall portfolio's weights and the portfolio's return and the risk corresponding to these weights. So, let us consider again a problem. Here the variance covariance matrix as given, the returns given as 14, 8 and 20, find the optimum. Our main task is to find out the optimum portfolio. But now remember, this risk free interest rate is also there. So, if this was not given, so say for example, the first set was not given, then obviously you could have solved it using the first technique, where you basically use the Lagrangian, find out minimum variance point, find out q, and basically join them depending on what is the correlation coefficient using the concept of two-fund theorem. Now, when in the case when you have basically the risk free interest rate, you basically use again the Lagrangian, but with the added the information that the risk free interest rate is already there. So, if you solve this equation using the n number of equations which are there each and with n number of variables, then the actual equation which you will get is this. First equation is R1 minus Rf multiplied by the normalized weight of the first into sigma 1 square, normalized non-normalized weight of the second into sigma 1 2, which is the covariance of first to 2. So, if you consider this graph or the matrix, if you for the time being suppose these W1s, W2s and W3s are not there, what you actually have is the covariance variance matrix which I had just mentioned. So, what you are doing is that multiplying the non-normalized weights in with their covariance variance matrix and basically equating to the left hand side, which is basically simply a difference of the particular returns and the risk free interest rate. So, given all the information which is already available with us, as is R1, R2 till Rn, Rf, sigma 1, sigma 2 till sigma nn, and all the combination of the covariances, you can immediately find out W1 bar to Wn bar. So, if you solve them, the W1 bars weights comes out to be like this. Verify them, they do not add up to 1. So, again we normalize them and then we find out the weights, they add up to 1. Check it for yourself. So, once the weights are found out, you multiply it by the corresponding returns of the each and every asset, and the value which you get is basically the value of the portfolio. Similarly, you can find out the variance of the portfolio also. SS allowed along, but riskless lending borrowing not possible. Again the answer is simple, you go in a roundabout way. First you take the tangent point. Now what you do is that keep changing RF, either on the upward scale or the downward scale. As you keep doing it, each of them would be tangent to, say for example, different points like Q1, Q2, Q3, Q4, so on and so forth. Join Q1, Q2, Q3, Q4 every one and then ignore the RFs. So, what you have is basically the efficient frontier, considering that there is no lending and borrowing on the risk free interest rate. That means, there is basically no risk free interest rate as such for you. So, assume a certain risk free interest rate is there for lending borrowing existing. We find out the corresponding optimum points for as we change the values of RF, continue doing so and join the points, and we get the efficient frontier. Now, the third case is riskless lending, this short selling disallowed along with riskless lending borrowing possible. Again go back to the same problem. For this we will basically have maximization of the theta value, which is the ratio of the height and the base, such that sum add up to 1, weights are basically greater than 0. For this we have some quadratic formulation, and we will not discuss it here, we will come back to that later on. But in case if we want to solve them, again we can find out simple techniques, what we have already done, use that in an extended way, and you can find out the efficient frontier accordingly. Third case is SS allowed is disallowed. Similarly, riskless lending borrowing is also not allowed. The problem takes us back to the same problem which we had initially discussed, Markovitch problem, where riskless lending borrowing is not allowed. So, obviously, for that we will have simple solution techniques using some optimization methodologies like simplex method and so on and so forth, and we can easily solve them using the MATLAB code, whatever it is, and get all the answer. Another way would be to go in a roundabout way, consider riskless lending and borrowing being there, or riskless borrowing not being there, or short selling being there not there, and basically eliminate those sets of points for which you basically there would be no riskless lending and borrowing being allowed, or neither short selling being allowed is there. Now, before we return to the case of trying to consider other constraints in the problem, remember one thing, important thing, and for that let us draw a simple diagram. Consider the riskless lending and borrowing is there, and you have basically the efficient frontier for the case where the riskless lending borrowing is not being considered. So, initially we had the curve, now we had basically the riskless lending borrowing such that any tangent point will give you the efficient frontier. Now, the question is, if this is Q, what you have is basically this is RF. Now, the question which many would be asking is that if I go to the bank, borrow money, if I go to the bank and lend money, are the riskless lending and borrowing same? Answer is not so, it is definitely not the same. Say for example, if I go to the foreign exchange counter and basically I buy dollars or basically sell dollars, then the rates are different for each of them. Similarly, if I go to the bank and I take a loan and deposit some amount as a fixed deposit or a recurring, obviously the interest are different. So, if we want to find out the efficient frontier for the case where the riskless lending and borrowing are different for lending and borrowing, then the curve can be drawn very simply like this. For one set of point which is RF1 and another point is basically RF2, which is the higher value is for the riskless lending and borrowing when I go to the bank and ask money from them. The lower one is for the case when I go to the bank and deposit money from them. So, initially assume the curve is given. Now, what you need to do is very simply like this: draw the tangent for the first case, draw the tangent for the second case. So, I am trying to use my skills, artistic sense here. So, what you have is this. So, let me use a different color in order to make it understand. So, actually what you have would be the frontier would go straight here. So, this is F1, this is F2, then there is a small portion of the curve which is curved, and that will be basically the combination of 2 points. This is Q1, this is Q2, where Q1 and Q2 can be found out from the case where you had taken the Lagrangian multipliers differently for different problems. And then if you want to consider riskless lending and borrowing mean there, this will be a curve. So, it means first a straight line, then a curve, then an extended straight line which may be dotted depending on whether you have riskless lending and borrowing being possible or whether short selling is allowed. So, with this lecture will now close for the case, for the simple cases where you are considering 4 combinations: riskless lending, borrowing being allowed, not allowed, and basically short selling being allowed and not allowed. So, with this one we will basically extend our problems for the other cases for the portfolio optimization cost later on, such that we can consider whether one may assume different combinations of the objective function, different type of constraints, such that it will be much easier to appreciate how optimization can be utilized in order to solve different portfolio optimization problems. Thank you.